So I do know you're just in quarter 2, but you're still taking biochemistry. So I will hopefully try to remind you every term. I'm teaching physiology again, so they're looking up chiropractic research, and I get so excited when I see some of the research coming out of chiropractic medicine and the potential that is out there, and other chiropractors are doing it, and you guys might know about all this great stuff, but no one's really publishing research on it. So Western medicine has not caught up with how awesome this field is, or the potential of it is. So yeah, my break was not very exciting. I don't remember a break. That's how boring my break must have been. So I hope you guys at least had some fun. I did hear one student went to the Grand Canyon and took a helicopter ride over the Grand Canyon. So I lived vicariously through her describing her spring break. So hopefully you guys had a better one than I did, but it wasn't bad. Getting some sleep, having some peaceful, relaxing days is not a bad thing. All right, are you guys ready to get started? So I normally have my iPad. As you know, I was switching to using my iPad, and then I just lost my iPad pen. I don't know where it is, so I need to tear apart my room. So that's why I don't have my iPad out right now, but I do plan on using that because I know how useful that is to show you guys what's going on. But for now, I'm going to use an old school method, which is a pointer. All right. So when it comes to biochemistry 2, we're going to do a little bit of review, and then we're going to talk about lipids. So here again, it's the same thing. Sorry, I forgot to mention this before, or show you guys before. But this is exactly what we just talked about. Everything's 25%, exam 1, exam 2, the cumulative final, and the weekly quizzes are 25%. So that's going to be your grade. And I used to teach this for nutrition, so apparently this slide is still on here. All of these slides are still on here. Okay. I guess maybe I haven't talked to you guys about this. So I guess one of the reasons I want you guys to know the scientific language is so you are going to be doctors, and you're going to have patients and clients who are going to be listening to what you guys say. And so I want you to understand this, not just for the boards, but for them, for the clients, for the physicians, and other people that are trying to listen. Because these questions are not easy to answer. And if you don't understand biochemistry, you can't answer a question like this. You're basically, if you're trying to answer a question like this, if you don't understand biochemistry, you're just going to be regurgitating what someone else says. As Neil deGrasse Tyson said, I think I've already told you this quote, if you don't understand the scientific language, you don't know when someone else is full of bullshit. So that's why you need to understand the scientific language, so you can understand and answer these questions. And if you don't know the answer, you can look it up, look at the research, and see what the research says, which the general population cannot because they don't understand the language. So that's kind of what this was about. But people think they know a lot, especially when it comes to nutrition, carbs, lipids, fats. People seem to think they know. But unless you can really understand the research, unless you can understand biochemistry, you really can't answer these kind of questions. So we've already talked about carbohydrates. That's probably the big one. It's got a lot of pathways that were really important, which is why this term is going to be a little easier because we are going to focus on fat and some of the protein. We're going to talk about the breakdown of protein. And these three are the most important nutrients, carbs, protein, and fat. And they make up the majority of this human machine that we have. Don't memorize these percentages. This is just kind of showing you an idea of the composition of this human machine. And I also want to remind people that we recycle our bodies every year. So every year you're a new version. And I feel like people don't respect that when they consume food. We put better food in our car than we put in our own human machines. And so just think about that. Every year you're recycling your body, and the food that you eat, the supplements that you take, whatever it is that you do, that's creating your new body for the next year. So these are older slides that I thought they didn't keep in here, but apparently they did. But I don't know. I like some of them anyway. If you know anything about grocery stores, stay away from the middle aisles. You're supposed to stay on the perimeter. That's where all the fruits and vegetables and meats and other products that are not highly processed can be found. But you have to then convince your clients to eat healthier, so that's the hard part. Did we already do the collagen deficiency? I think we did. So these slides are something I need to get rid of. Okay. So something is a lipid if it does not like water. So lipids are hydrophobic. And these are some of those lipids that we're going to be talking about in this class. So fatty acids, and the orange part is actually what is the lipid. So remember how this works. Every time you see this kink right here, there's a carbon. So this is actually has lots of carbons. This is a hydrocarbon tail. This is another hydrocarbon tail. So this orange here, I kind of want my iPad right now. But you see this here, this actually is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons are on this orange chain here. So this is a long chain of carbons in each one of these, and these two have a kink. So every time you see a long chain of carbons, that is not going to like water. These are always going to be hydrophobic. Another word for hydrophobic, or one that we can use interchangeably, is, you guys tell me, is it polar or non-polar? Which one is hydrophobic?
Polar.
I like the guessing, some people are guessing. It's non-polar. So polar likes water. Non-polar does not like water. So you could say that polar is hydrophilic, water-loving. Non-polar is hydrophobic, water-fearing or water-hating. Someone said that polar bears like water, so that's one way to remember this. If you've ever seen a polar bear swimming in water, polar, water, water-loving. Non-polar is hydrophobic. So I could have just easily said non-polar portions of the molecule. But these are all parts of the molecule that do not like water. They are hydrophobic. And here is the special one. This 4-ring structure, so there's 4 rings, 1, 2, 3, 4. This is a sterol compound, a steroid. So cholesterol has a 4-ring structure. You're going to be able to always recognize cholesterol because it is a 4-ring structure. It does not look like the other lipids. But the reason it is a lipid is because it does not like water. So if something doesn't like water, it's going to be a lipid. Well, I shouldn't say it like that. It could very well be a lipid. So hydrophobic, all your lipids will not like water. And steroids are just an example of that. So it doesn't look like the others because it doesn't have that fatty acid chain like this. But it's still hydrophobic. Does not mix with water. And this other one down here we'll talk about some other day. It's going to be a little more complicated. So all lipids do not like water. They are hydrophobic. They fear water. So water is polar, lipids are nonpolar. So you can't dissolve lipids in water. If you've ever made salad dressing with olive oil and some sort of vinegar, you know this. You have to shake it up to try to get them to mix together. general function of lipids. We're going to talk about each one specifically, but we need lipids for a lot of reasons. One, we need them for energy. So you have about 100,000 calories of fat on your body. I slap my thighs because this is where I carry most of my fat. We have about 100,000 calories of fat stored in your body. So it would take a few weeks for you to starve to death. Cell membranes and organelles. So your cells are made up of phospholipid membrane. You probably know that from your other classes. Steroid hormones. So your sex hormones, testosterone and estrogen, are steroid hormones. They're lipids. There's some others as well. Cortisol is another example of a steroid hormone. There's specialized lipid tissue like sphingomyelin. Sphingomyelin is a type of tissue that is used in your nervous system. They insulate the body, so one of the reasons I'm so hot is because we all have a layer of fat underneath our skin, and that keeps us warm. And it also cushions our vital organs, so it keeps them safe. So these are all just general functions of lipids. And this won't be on the exam. Well, some of it will. You have calories in your fat, so 9 calories per gram. Yeah, that's right. 9 calories per gram when it comes to fat. How much is it for carbohydrates? How many calories per gram are carbs? 4. So you guys will be ready because we will have a test over that. That'll be exam 2. But there are other things. Obviously, fat in our foods is really important for aroma, for taste, the creaminess of the texture, satiety. It helps you feel full. So there's a lot of reasons we have fats in our food. I will point out we also need fat. This is something we'll talk about later. We need to eat fat in order to absorb our vitamins. So some of our vitamins are fat soluble. Do you guys know which ones they are?
Vitamin D.
D, K, A, and E. Those are our 4 fat-soluble vitamins. If you don't have fat in your diet, then you're not going to properly absorb the fat-soluble vitamins, which are A, D, E, and K. And these we'll talk about more in the second term of the class. We'll talk about a lot about the vitamins and minerals. And the essential fatty acids. So omega-6 and omega-3 are 2 fatty acids that our bodies cannot make. And so we have to get them from the diet. If we don't get them from the diet, then we'll have a lot of deficiency issues, mainly neurological issues, if we don't get these essential fatty acids from the diet. But we'll talk about them later as well. So the structure of a fatty acid is important to understand in order to think about what it's doing in the body. There's 2 types of fatty acids. Well, there's more than 2, but the 2 main ones we're talking about are saturated versus unsaturated. So the structure of fatty acid depends on its hydrocarbon chain. So hydrocarbon. I feel like I've lost a limb without my iPad, quite honestly. There's so many things I want to do. So the hydrocarbon chain is a long chain of carbons with hydrogens attached. And actually, you'll be able to see it, I think, in the next slide. I'm just going to show it. Here you go. This is a fatty acid. It's a long chain of carbons, and there's a hydrogen attached to these carbons. And so we call this a hydrocarbon tail. Fatty acids have basically just hydrocarbon tails. And there's 2 ends to that tail. There's a methyl end and a carboxyl end. So if we go back to that picture, is this the carboxyl end or the methyl end?
Carboxyl.
Carboxyl. You guys did learn something from last term. So this is the methyl end. So there's two ends to the fatty acid. This is the carboxyl end. This is the methyl end. The carboxyl end is hydrophilic. Oh, I misspelled that. There's a lot of typos in this that I need to get corrected. So, but we'll survive. Luckily, it's multiple choice for your exams. So, what I mean by, so this portion here, if you remember last term, this can become deprotonated. So this likes water. This is the only hydrophilic portion of a fatty acid. The only part that likes water. The rest of this whole big thing does not like water. Oops. So there's a polar end, polar hydrophilic, and then the most of that fatty acid is nonpolar hydrophobic. That's the methyl part. And the chain of the fatty acid can be short. It can be only 4 carbons long, but it can be upwards of 24 carbons. So fatty acids can be short or they can be very long. And we call them that. We call them short chain, medium chain, long chain, and very long chain fatty acids. That's how we describe them. Short, medium, long, or very long chain. So 4 would be short, 24 would be a very long chain fatty acid. And they can be saturated, monounsaturated, or polyunsaturated, or a combination. And we're going to talk about the saturation in a second here. So you've heard of saturated versus unsaturated fats. Which one is healthier, saturated or unsaturated fats?
Saturated. Saturated.
I love how we just throw things out. It is unsaturated. You probably just heard it from the news, general population stuff. Unsaturated fatty acid. Is olive oil an unsaturated fat or saturated fat mostly? Unsaturated. So these guys are things that we talk about in the media, in public, but we don't understand what it means. So I want you guys, today you're going to be understanding the difference between saturated fats and unsaturated fats. So again, fatty acid is a chain of carbons and hydrogens with a carboxyl group and a methyl group. The chain will vary by length. So again, they can be short, medium, long, or very long chain. It also can vary by whether the carbons have a double or single bond between them, and by the total number of those double bonds. So this will tell you whether something's saturated or unsaturated. A saturated fat has all the carbons bonded to hydrogen. In other words, it is completely saturated with hydrogens. A saturated fat is completely saturated with hydrogens. Versus an unsaturated fat. Unsaturated means there's at least one double bond between the carbons, which means it is no longer saturated with hydrogens. And I'm going to show you what that looks like, and I'll come back to the slide. So here's a saturated fatty acid. It's saturated with hydrogens. Here is an unsaturated fatty acid. Notice it is no longer saturated with hydrogens. There is at least 1 point of unsaturation. And some fatty acids have 2 or 3 points of unsaturation. So there can be multiple double bonds. So when there's a double bond between carbons, it means, remember, carbons can only make 4 bonds. And so if there's a double bond, it can't make another bond with a hydrogen. So that's a point of unsaturation. So if we go back to this slide, an unsaturated fatty acid has 1 or more double bonds between carbons, meaning it's less saturated with hydrogens. That's it. That's the difference between saturated and unsaturated. There's a double bond between carbons with unsaturated. and I'll get to this more with liquid at room temperature in a second here. But there's two types of unsaturated. You can have mono unsaturated or polyunsaturated. Mono unsaturated means there's only one double bond. The most, and this could be on your board, so it probably doesn't hurt memorizing this one. Olive oil is a mono unsaturated fat. I actually saw that as one of your board questions in this sample copy that I've been given. I'm like, oh, they need to know that? I thought that was surprising. But yeah, monounsaturated fats, olive oil is a really good example of that. Polyunsaturated fats means there's more than one double bond. There's at least two. So an example of this are going to be your omega-3s and omega-6. So linolenic, alpha-linolenic is omega-3, and linoleic is omega-6. And we'll talk about these later, so don't try to memorize them now if you don't want to. But your essential fatty acids are actually polyunsaturated fatty acids, meaning there's more than one double bond. Yes.
And then as far as like what you're looking at for the boards, could you give that to us too?
I don't think I can.
Okay, all right.
At least not at this time. If you get, when you guys get up ready to do the board, I'm looking at it for you guys as I'm prepping these biochemistry courses. I want to focus you guys on what you really need to know, and give you like a good sense of biochemistry at the same time. I can do both at the same time. But yeah, if you're ever studying for the boards in a couple few terms and come back and talk to me, I can help you. I'm happy to help. But yeah, I am looking at something to help me figure out what you guys need to know.
Nice.
So again, here is saturated. So it's saturated with hydrogens. Fatty acid is carrying the maximum possible number of hydrogen atoms, having no points of unsaturation. So saturated fats are found in animal foods. Animal foods have a lot of saturated fat. So butter, lard, steak, hamburger, pizza. Most of these are saturated fats. And the reason I mention this is because it has been shown in the literature that they do increase risk of cardiovascular disease. Why that happens, the etiology, the reason for that is unclear. But we do know that people who tend to eat a lot more animal fats versus plant fats tend to have higher rates of cardiovascular disease versus unsaturated fats, whether it's monounsaturated or polyunsaturated. So here's just a monounsaturated. These guys are related to lower risk of cardiovascular disease. And that's in part because of LDL and HDL, which we'll talk about later, your good and bad cholesterol. We'll talk about those in a couple of weeks. One raises your risk for, so LDLs raises your risk for cardiovascular disease, and HDLs lower your risk. And so it's going to relate back to saturated versus unsaturated fats. But this is another thing that you guys need to understand when it comes to unsaturated versus saturated is how their behavior. So saturated fats behavior is different than unsaturated. You can tell what type of fat you have in your pantry just by looking at it. You can tell if it's more saturated or unsaturated with fats. And assuming you can see the fat. For example, coconut oil. Is coconut oil, maybe not on a day like today, but is coconut oil, generally speaking, is it solid at room temperature or is it liquid at room temperature? Solid. Solid tells you that it is more saturated. So saturated fats, so I should say unsaturated fats. Unsaturated fats, every time you have a double bond, it creates a kink in the chain. And when there's a kink in the chain, the fats can't sit on top of each other because they're kinked. So what happens with saturated fats, there's no kink. And so butter is a good example of that. There's no kink because there's no double bonds. So it's just a linear chain. And so these guys can actually sit on top of each other and create a solid at room temperature. But olive oil is liquid at room temperature. And that's because these double bonds create a kink in the chain. And that kink in the chain means that they cannot sit on top of each other, and that makes them liquid at room temperature. So a steak, if you look at a steak, it's not oozing with oil, it's solid. Steak will have more saturated fats. Bacon, delicious bacon has more saturated fat. It is a solid fat at room temperature. You have to cook it, and then you see the fat start to melt. But that's how you can tell whether something's in your pantry is full of unsaturated, more unsaturated, or saturated fats. And just so you know, it's not one or the other. For example, olive oil has saturated fats in it. It's just mostly unsaturated. Butter has unsaturated fats in it, but it's mostly saturated. So they are not one or the other, it's just which one dominates. In butter, you have mostly saturated fats, that's why it's a solid at room temperature. Yeah.
Specifically with looking at saturated versus unsaturated fats, how would you recommend that we decide what is and isn't good for us, in the sense that if you talk to some people, they're like, I'll only eat butter, stick whole, and then other people are like, no, get olive oil, how?
And then some people are on the bandwagon of coconut oil.
Yeah.
And I will say the research, we don't know. And I always treat everyone as an individual, honestly. What are their preferences? I had one of my graduate advisors, and nutrition graduate advisor, one of the students told her that she switched to coconut oil because she thinks it's healthier, because coconut oil is also medium chain. Medium chain fatty acids are treated differently than long chain fatty acids. So that's another thing that plays a role in health. Coconut oil, even though it's solid, even though it is more saturated, because it's more of a medium chain fatty acid rather than a long chain, because butter is a long chain fatty acid, then that changes the dynamics in the body, and coconut oil might be healthier, even though it's saturated. And your question is really good, but I don't have a good answer for it because we don't have a lot of great research yet. The problem with humans is that we cannot lock you up in rooms and do studies for 20 years. I think they've tried doing that sometimes. In the past, they actually did do that, but we can't do that anymore. There's ethical reasons why we can't lock people up and do these studies on them anymore. But yeah, we just don't have any good studies. So I look at if someone asks me a question, I will try to look at the most research on it, but at the same time, there's a lot of limitations to those studies. So I don't have a good answer. We just have to do the best we can with whoever comes in front of us and whatever their questions are, and do our best trying to figure out what might be best for them. But yeah, I wish I knew. Yeah.
To kind of go off of that, there's a lot to say is. So when I did keto, it's high fat, right? So it's really successful for me, and I've actually really helped my health.
Oh, my sister is a ketogenic, and she loves it. Her health has been great since she started it.
So I ate a lot of olives, a lot of olive oil. I did a lot of butter.
Yeah.
But I think what really helps is that you do the fats without carbs. When fat by itself is the bad thing. But when you combine, if I were to eat that with butter and all that fat, and then have those breads and the carbs and the pastas,
Yes.
that's what does damage versus just.
But having said that, and this is another thing I'll throw in the mix, is that we don't know what happens with someone who's on a ketogenic diet for long term, because we only have short-term studies showing benefit. And so I question what that looks like long term. We know that high carb sugar diets long term are not healthy. But people who are on these healthier ketogenic diets, like my sister, she still eats carbs, but they're high fiber carbs like broccoli and kale and salads and things like that. She doesn't eat bread. But my diet is almost like 80% carbs. And I know my human machine though, and I'm very focused on my human machine. Like I listen to it very clearly. And so I still go back to the individual. But if you have something that works for you, then you will probably draw clients that are interested in that working for you and how that works, and you can help them figure that out. Because there's a healthy way to do it, you're right, and there's a way to do it where it will not work. So that's just another angle to look at this, but there's still no good answers. But I agree with you, like there's a way to do it that might really work for someone like you or my sister or someone else, but for someone else, it still won't work for them. Like I think I might go dizzy and pass out if someone tried to put me on a diet like that. Because but it's partly because I've trained my body differently. And you also have to think about how someone trained their physical machine. If they've trained it for 30 years doing X, Y, Z, and we switch them to something, I'm going way into like my background, which is nutrition consultation. So, but I could really get into this a lot more, but I don't want to spend too much time on it. But yeah, I mean, I think there's so many ways to be healthy is what I'm trying to put out to you guys. And so you can formulate your clinic, whatever chiropractic clinic you want, if you want some sort of nutritional advice that you want to give people. Again, this is a good reason to understand biochemistry, because you can be able to explain this to them and have research or know how to validate or explain it to them in a scientific way about why it might work for them. I feel like that's telling us it's the end of the day. But we definitely need breaks.
Yeah.
Yes, we do.
Just a quickly before we go.
I am doing quickly. Very quickly.
Sing it now, you got your sister.
That's what I'm saying.
That's the disrespect.
Something about a maple leaf. What?
What's okay? Go.
That's what I just said. Something about a maple leaf. Polar bears.
This is so rude. I know you're actually.
That's not the quickly.
For the most part, right now.
About the farther. Did you bring the right shirt?
What?
Did you bring the right shirt?
I did. I might have to. I don't like to say. There might be something we need to do.
Check in.
It's so nice. It's so nice outside.
It's a little hot.
Maybe the
It's just because I'm in Sorry.
Honestly, if you could stay in here this time.
It's the same thing. You have to go passport. Do all that.
What?
Yeah.
Yeah, then you're in.
What? Good. The more you know, bro. Find out something.
That's why your friends don't know.
You probably teach me so much. It's actually insane. Tell me. Where would I do that? Teach me so much. Wow. I'll never do quickly on my phone.
No, you have to do it.
Oh, J.M., my brother in Christ.
But you don't have to have had 15 years. So yeah, I would say you need a bachelor's in not just nutrition, but dietetics and also. I would would say that probably not the best thing because just classes, functional foods, whatever lipids that we learn, and I would just spin it that way and
That was nice, right?
but I do like the
I tried to harmonize with him because he was kind of black.
I wasn't even trying. Gosh. I would expect nothing less.
My pride of your pride of I'm always playing your pride.
yeah, I'll think about it. If there's someone else who's thank you very much. Oh yeah, I did do this one time I use that as a way So I'll make sure I've had this dropped off either today or tomorrow. Yeah, if I then I'll I used to make fruit. Everyone, the sooner we get started, we'll just go, well,